Okay, good afternoon, everyone. Thank you for taking the time to make it to today's online session. My name is Daryl, and I'm with Midas, and I'll be giving the introduction to our upcoming geotechnical courses today. So once again, you are currently registered in the Midas Elite Center. Elite stands for Enhanced Learning in Technology and Engineering. So as far as the overview of this introduction, what I'll be going over is who we are, which is just an introduction to our company, what we do, and how we can help you as far as professionally. And then we'll also be going over the Midas Elite Center, why it was started, certain things that we aim to do through the center, certain opportunities for continuing education, both past and in the future as well. And then next we'll be going over the course summary for this particular set of online sessions. So we'll be going over essentially just the syllabus, the schedule, which you can expect to learn about during each session. And then last we'll be going over what we offer. So we'll also discuss certain software packages that are available that we'll be introducing throughout the length of these courses. Okay, so first who we are. So Midas is currently the world's leading engineering software developer, and our purpose is to share technology and knowledge that will enable engineers to more effectively accomplish their goals. And so currently we have a company size of about 450 engineers. We were started in 1989, and our headquarters is currently in Seoul, South Korea. But as you can see, within a short sort of time frame of getting started in 1989, we've been able to establish a worldwide presence due to the quality of our products as well as the reliability of our services. So currently I'm broadcasting from New York City, and we handle the North American clients here from this New York branch office. But also we have offices in England, in Russia, and then several offices in Asia, in Japan and China, India as well. So just keep in mind that Midas is it's a very strong worldwide presence. Our software is used around the world by literally thousands of engineers. Many high-end projects have been completed successfully with Midas software, as I'll show you shortly. So just keep in mind that with our products, you can work more efficiently as far as your design, and you can also start to approach projects maybe that'll be. Okay, good afternoon, everyone. Thank you for taking the time to make it out to today's online session. My name is Daryl Saraspe. I'm an engineer here at Midas, and I'll be providing the introduction session today. So currently we're enrolled in the Midas Elite Center. Elite stands for Enhanced Learning in Technology and Engineering. So first, let's go over an overview of what we'll discuss today. First, I'll give an introduction to who we are as a company, our services, our credentials, and how we can benefit you, and how our services can aid you in your own work. Next, I'll be going over the Midas Elite Center, specifically why it was started, certain opportunities as far as continuing education that are available to you through the center, as well as offers for our geotechnical software, which we'll discuss in greater detail. Next, I'll be going over the course summary. So essentially, I'll just be going over the syllabus for the course, the scheduling, and what specifically you can expect to learn on each day. And then I'll go over what we offer. So because it's nearing the end of the year, we do have some special offers on our software, which we'll discuss in greater detail. So as far as who we are the world's leading engineer software developer. And our purpose is to share technology and knowledge that will enable engineers to more effectively accomplish their project goals. So currently our company has about 450 engineers employed worldwide. We were established in 1989, and our headquarters are currently in Seoul, South Korea. But within a short time frame, we've been able to establish a worldwide presence. So as you can see, we have a total of 6 branch offices. Currently, I'm broadcasting from our New York City branch office, which handles all North American clients. And we also have offices in England and Russia as well. We also have a very strong presence in Asia, especially in China, Japan, and India, where we have branch offices there as well. So just keep in mind that Midas software is being used around the world by literally thousands of engineers. Many high-end projects of note have been completed with our software, and we're known for our reliability, for the high quality of our programs. And we hope that you'll be able to take some more time to learn more about how our software in particular can help you with your own projects. And here's just a couple of notable clients of ours. Some of these may be familiar to you. So these companies were all sort of leaders in the industry. They all are reliable users of our software. They use our software regularly. And also we worked hand in hand with them to establish technical partnerships where we provide project support and consulting. We have a long list of clients. These are just a couple of clients that we have, just some of the more notable ones that work in the geotechnical industry. But we also have clients that work in the structural and the mechanical engineering industry as well. Okay, and as far as what we do, as I said before, we pride ourselves on being technical partners. So we're not just developers and marketers of software. We actually pride ourselves on being able to enhance engineers' abilities, not only through the software, but also through their knowledge. That's why we have multiple events throughout the year, specifically for engineers to discuss new design practices, to design high-end projects, and to design, to discuss new innovations in the engineering industry that we want everyone to sort of be aware of so that they can take advantage of them. So as you can see, we recently had a seminar in New York for bridge engineers. These are just a couple of snapshots of the event. We had a very good turnout. And also we also have worldwide events. So as you can see, these are just conferences from various regions or various parts of the world, every from Italy, United Kingdom, to Korea and Indonesia and Spain. So we truly do have a worldwide presence, and many engineers are familiar with our course opportunities as well. So that's something that we hope that you'll be able to take further advantage of in the future, is just these opportunities to continue to learn and to develop and to grow as professionals. Oh, and before I move forward, I just also want to make note that aside from having these large group conferences, we also are available or open to setting up customized training sessions as well. So for example, say later on there's a particular project type you'd like to discuss, or something in the seminar or the upcoming seminar that is of interest to you that you'd like to discuss in further detail. I can talk to you directly, but you can also contact us for maybe a more customized session. So we don't only offer seminars in groups, but we also offer individual customized seminars for maybe individuals or individual offices. So that's an option that's you're more than welcome to take advantage of. Okay, so and also this is just the sort of diagram of how we sort of work with our clients. So right now, this is the very beginning stage, the introduction. So right now, you're still just learning about us, you're learning about what we do as far as not only software, but also continuing education. But later on, we'd like you to evaluate our services. So as you attend our courses, naturally you'll be evaluating them, seeing if they're of use to you. And also, we hope that you'll take the time to evaluate our software as well to see if it's something that could be of greater use to you guys in the future. And then naturally, we'd hope that you'd be able to, in the end, make a purchase of the software of a particular program, so that way you can implement what you learned in these courses into actual projects that you're working on through the use of our software. So after the software is purchased, or after you acquire this new program, that's not really the end of the relationship. In fact, it's just the beginning. After the program is purchased, we make a note, or we make a special effort to provide individualized training, so that you'll be able to learn how to use the program very quickly, that you'll have all your you'll have all your questions answered, and that you'll be able to have someone to sort of turn to for guidance and direction. Usually myself or one of my colleagues, after you start using the software, will be assigned to help you and to provide direct project support. So training and technical support are two key services that we provide for all engineers, not just first-time users, but also long-time users. Ultimately, our goal is to help you become experts, not only in numerical modeling, but also just in your respective fields. So we feel that aside from our programs, we also have another very important thing to share and to offer, which is our technical knowledge. So we hope that through partnering up with us, that you'll be able to enhance your skills and become even more proficient in your services and in your abilities. And then also technical seminars. So even after you've sort of reached an expert level skill set as far as numerical modeling, there's still always new things to be learned. We do provide, upgrades to our software periodically. And then we also have technical seminars where we'll have certain clients who have used our programs, who have had success with particular projects of note. We'll have these events where you can come and attend. You can continue to learn more. So learning, it's a continual process. There's no real end to it. We're always sort of building upon what we've already learned in the past to reach even higher levels of excellence. So that's what our main goal here at Midas is. We want to give you, help you to develop a skill set to work more efficiently, and then also we want to give you the tools to work more efficiently, which is where our software comes in. We've had sort of clients that have been with us for years, and they still regularly attend our seminars to keep on learning. So that's what we hope to develop here today, is we hope to develop a relationship that can be long-standing, in which you can continue to learn and grow, and you can continue to take advantage of our services to better sort of improve yourself. And then also, some of you are probably wondering what this picture represents. This just sort of goes over how we go from the very beginning of the project to its completion. So here to the very left is just a picture of the sort of an initial AutoCAD drawing. And what we do for clients is we help them from the ground up. So we'll get the drawing for them, we'll help them do their model, and then we'll help them create a finite element model, which will then be used to do analysis and design work. So just keep in mind that if you decide to do business with us or to send your projects over to us, we'll be with you from the very beginning to the end to ensure that everything comes out okay. Okay, so some of you are probably wondering what exactly our software is, or what sort of forms it comes in. So here is Midas GTS, which is our three-dimensional finite element analysis design software for geotechnical and tunnel projects. So the main thing to remember about Midas GTS is that it's sort of geared towards higher-end analyses and projects. So any sort of complex geometry, any sort of high-end needs, construction stages, things of that nature, Midas GTS can handle it. So as you can see to the right here, it handles all of these project types, everything from deep foundation, soil structure interaction, unconventional tunnels, excavations, groundwater flow for dam analysis, and then also seismic analysis. So it's essentially an all-in-one software package which can handle project challenges or projects that are very large in scope. But also keep in mind that it can handle conventional projects as well. Here's just a couple of examples of what Midas GTS has handled in the past. So there's a tunnel project in Hong Kong. This was handled by Arup. And just using Midas GTS, they were able to design sort of complex tunnel intersections, both in 2D and in 3D. And this is a project that's gained some note in a recent tunneling journal. And we got a very good review in which our software was described as something that was tried, tested, and trusted. So our software has been used for many years now by many leading companies for many high-end projects. This is just one of note. So we hope that once again you'll take the time to take a look into it over the course of these sessions. And as you can see, just from the diagrams here, these are just sort of stress contours or deformation contours. And just using Midas GTS, the engineers were able to design tunnels that were very stable, but they're also very economic. Ultimately, our software helped them to save a lot of money by cutting down on design times as well as the cost of construction. So once again, any sort of design challenges that may come your way, Midas GTS is fully equipped to handle that, to overcome that. And then here's just the tower in Dubai. As far as this tower, this is called the D1 tower. It's about 80 stories tall and 930 feet total height. And as far as the foundation, Midas GTS was used to design the pile raft foundation as well as these basement levels. So as you can see here, there's sort of the initial sort of stages of the model. So the model was rendered in full 3D because of the scope of the project and also because of its particular shape. So once again, this is just another example of a very high-end project that was completed successfully with Midas GTS. And then also the Odeon Tower in Monaco. This is actually something that we'll be going over in greater detail in one of our courses. This will be one of our case studies. But just as a basic introduction, the main sort of tool, or the main sort of function that GTS served, was to perform an analysis for the foundation that was being dug out in this area here. So there was, I believe, a school as well as some neighboring buildings, and the engineers wanted to make sure that the excavation didn't negatively affect or compromise the neighboring adjacent structures. So as you can see, each one of these bands represents an excavation sequence. So they did it sort of piece by piece, just to see how that how the nearby foundations would be altered by each stage of excavation. And then afterwards, the engineers are also able to create a construction stage analysis. So they're able to simulate the construction of these various basement levels as well as these anchors here. So they're able to design sort of the best, most economical foundation for this particular project, just using Midas GTS. And so once again, we'll talk about this in greater detail in one of our courses, but I just wanted to sort of introduce you to how Midas GTS has been used for a wide array of projects, not just foundation projects, but also tunneling, and also excavation, construction stage sequencing projects as well. Okay, so in addition to GTS, we also have another software called SoilWorks, which is two-dimensional geotechnical software for practical design. So just think of SoilWorks as the software that's used for more conventional, smaller scale, everyday type projects. Midas GTS is an excellent software package, but one thing about it is that it's a very sort of high-end, or it has a lot of sort of commands. And it's typically used for projects that are much larger scale. So for those of you who maybe work on maybe smaller scale projects, or projects that don't require such a high level of analysis or such a high level of detail, SoilWorks is more geared towards maybe the projects that you work on, once again, on the day-to-day basis. So even though it's sort of a smaller package, it's more limited in its in what it can do as far as higher-end projects. But if you're using it for example, a simple slope project, a simple foundation project, something that you typically could do maybe with a spreadsheet or another software package, SoilWorks is, essentially something that could be of greater use to you. So as you can see by this picture here, you can handle pretty much any sort of analysis type. And another really great thing about SoilWorks is it isn't just finite element analysis software. It also handles conventional types of design approaches as well. So as you can see, in addition to SRM, so for slope stability, in addition to the strength reduction method, which is a finite element analysis method, it can also incorporate the limit equilibrium method. So I'm sure all of you who do slope stability are familiar with LEM. So that's one of the great things about SoilWorks, is that it takes the best things of finite element analysis as well as the best of conventional methods, and it combines them into one overall program that can handle everything. So once again, just keep in mind that Midas SoilWorks and GTS are both really great geotechnical packages, but it really depends on sort of the scope of work that you're doing. That would sort of decide which one works best for you. And once again, we can talk more about these programs in greater detail. I just want to sort of introduce them out to you right now. And then, so here's just an example of a 3D slope stability analysis project. So the main difference between one of the main differences between Midas GTS and SoilWorks is their ability to do 2D and 3D analysis. So one of the main things I want you to remember about GTS is that it's more geared towards 3D analysis and design. So if you have maybe project geometry that's a little more complex, or maybe that can't be modeled in 2D, then GTS would be the better fit for that project. So here's a slope, done in 3D. But most slope stability projects, they can just be done in 2D if, it's symmetrical, or if you have maybe a longer type slope that's maybe long in the sort of longitudinal direction. So this is how it would be done in Midas, or how it would be done in SoilWorks. So as you can see, they can both be done in finite element, but SoilWorks is more geared towards 2D analysis. The command and the interface is much simpler, and it's sort of geared towards 2D design. And then here, once again, is a sample excavation problem. So for, maybe projects where you want to model them in 3D, here's a screenshot from GTS. As you can see, it's very detailed. You can take sort of a cut along any sort of side, and you can get, render your model in full 3D. So it takes a little bit longer to do, but if that's something that you feel would benefit your project, 3D modeling, then GTS would be aptly used. Whereas if you have a project that can, best be done in 2D, or you feel like it would be most efficient to do it just in 2D, then SoilWorks would be a better fit. So as you can see, SoilWorks can do finite element analysis as well, but it's more restricted to 2D type projects, or projects that are simpler or smaller in scale. Okay, so now let's talk about the Midas Elite Center, continuing education for professional engineers. So what is the Elite Center? Mainly what it is, it's an opportunity to learn about modern design methods that offer powerful solutions to geotechnical design. So it's not strictly for software. In fact, for the most part, we won't really be talking about software. We'll be just talking about finite element analysis and conventional design methods, and sort of how these methods sort of compare against each other and what they can be used for. And we'll also be going over certain theoretical concepts that every engineer should be familiar with. But here are just some examples of some projects that we've discussed in the past. So we had a new subway complex that was constructed in the United States that was talked about a couple of months ago. And then also the Buhang Dam in Korea. In that we talked about sort of new methods as far as seepage analysis and how that relates to slope stability and how it was handled for this particular project. So because of certain design considerations that were unique to this project, a lot of engineers were interested in how it was completed, especially over out in Asia, in Korea. So we had a seminar to discuss that. And then also the Dubai Tower in Qatar, the pile raft foundation, as well as the basement that was created. That posed a lot of interesting design challenges as well, because it's one of the taller buildings in the world. So a lot of engineers wanted to see how that design process was completed. So these are just three examples of sort of larger scale projects that we discussed in the past in the Elite Center. So something that's really special about this particular course is that it's not just one session. It's actually a series of 4 sessions that are closely related, and they'll sort of build upon each other. So once again, another thing I want you to remember is that all of our courses, by attending our courses, you can earn professional development hours towards the maintenance of your licenses. So why exactly was it started? So it was started to increase awareness of useful innovations in modern design practices. So that's just something that I really want to stress, is that these courses aren't really just about software. It's really about engineering and what's new in engineering. So one of the key things to being successful in the industry is being up to date with latest innovations, new design practices, what's going to help you remain especially competitive in today's market. So what we'll do is we'll be sharing all certain things that you can do just to ensure that you're sort of ahead of the curve, that you understand what sort of changes are coming and what you can do to incorporate those changes or those upgrades into your own design practices. So as far as innovation, what is possible with technology? So obviously we'll be talking about finite element analysis and how that relates to numerical modeling programs, and we'll discuss specifically what sort of unique answers or optimized results that you could get using these programs or using these methodologies. What is desirable to users? So we'll discuss, obviously what engineers are looking for in their design and how they can relate that to new methods or new technology that's out there. So something that we really stress upon is, working more efficiently, getting designs that are more optimized and economical. That's how you remain competitive. And you can do so by taking advantage of this new technology and new methods that are out there. So we'll be discussing that in detail over the course of these sessions, how you can use new technology to sort of bridge the gap to get better efficiency, to get better results, and to be able to take on more challenging projects. And also, of course, what is viable in the marketplace. So as far as developing your skills, it's really important that you keep yourself marketable, that you constantly develop an engineering skill set that's useful and that's developing or it's moving forward. So what we really want to do is we want to help you become we want you to be able to contribute more to your company, to the value of your operations, so that ultimately, by improving yourself, by improving your own skill set, you can improve the success of your company, and then, future job opportunities as well. So it all comes together just through innovation and applying what you learn in these courses. Okay, and another reason why it was started, we wanted to provide a convenient continuing education continuing education opportunities for engineers. Something that's sort of restrictive about those conferences that I showed you earlier was that they're sort of regional in nature. In other words, only engineers from a certain region can participate. That was sort of a huge shortcoming. We wanted to make sure that engineers from all over the world, regardless of the location, had the opportunity to take advantage of our courses. So that's another reason why we started these. That's the reason why we started having these courses online, so that instead of having to take a day off or an afternoon off to travel to go to a conference, what you can do now is you can just schedule it into your workday. So maybe during lunch, that's why we have it during 3 p.m. Eastern Standard Time, because this sort of fits better into your lunchtime schedule. Instead of having to take a day off of work, you can just come in for maybe an hour or so, take the course, and at the same time you can earn professional development hours towards the maintenance of your license. So that's one of the key reasons, is just to be more convenient. Okay, and then another reason why it was started, obviously we wanted to provide more engineers with opportunities to benefit from our numerical modeling programs. So at Midas we have, over a dozen different engineering software packages, but mainly we just want you to focus on SoilWorks and GTS. These are our two main geotechnical engineering packages, and as far as the main differences between the two, just keep in mind that SoilWorks is for conventional sort of everyday projects, and it's used for 2D analysis, and once again it handles the whole array of geotechnical design and analysis, so everything from slopes, seepage, foundations, seismic analysis, so on and so forth, SoilWorks can handle, but just on a sort of smaller 2D scale. Whereas with Midas GTS, it's for higher-end design and analysis for larger scale projects, more complex projects that need to be rendered fully in 3D. GTS is more geared towards those types of project applications. And once again, we'll talk more about these two packages later on near the end, and how you can sort of get more information about them and how you can actually get a free trial version so that you can try it out for yourself and maybe model some of your own projects on it to see how it works for you. Okay, so as far as the course structure, so our course structure for sort of each session follows a very sort of rigid sort of guideline or set. So as far as the background, first we'll talk about general project applications. So for example, if we're talking about slope stability analysis, we'll talk about what it's used for as far as in the field. Also design variations, so different ways that this type of project is designed or used. And then also there will be a quick quiz. So, don't worry about the quizzes. They're very straightforward. You just do them online. And they only contain 3 questions. It's multiple choice, and it's all done just through the website. So what will happen is, after the section is done, we'll have a 5-minute quiz. I'll bring it up, and all you have to do is complete it just online and submit it. And once you're done, we'll move on to the next section. So once again, it's very easy. It's very straightforward. And later on, we'll go over or actually we'll be given the quiz answers later on. Next, we'll talk about conventional methods. So the reason we're talking about conventional methods is because these are the methods that, everyone's sort of used to, or everybody's familiar with. So for example, like with slope stability, we'll talk about the limit equilibrium method. That's the most widely used method in sort of engineering for geotech. So we'll talk about that and the theoretical background. So oftentimes engineers will use a conventional method often, but they'll maybe miss out on certain theoretical principles, or they won't fully understand why they're using a certain equation. They're doing it a certain way. So what we do is we answer those questions in this section. We'll answer how this conventional method came to be, how it was developed, and why certain equations or certain methodologies are used. And then we'll talk about advantages and disadvantages. So naturally, there are some great advantages to conventional methods. They're widely used, so obviously, they're very easy, they're very efficient, but typically they come with disadvantages as well. Oftentimes, there are certain assumptions that need to be made, or there are things you're missing out on by not having an analysis that's maybe more high-end or detailed. So we'll discuss those in detail in that section. And then once again, we'll have a 5-minute quiz, multiple choice. Okay, and then the third section, we'll talk about finite element and numerical modeling methods. So just think of section 2 as sort of a review of what you already know. And now section 3 is where we're going into sort of new design methods, or methods that are sort of becoming more and more prevalent as numerical modeling starts to become more commonly used by engineers. So we'll talk about the theoretical background. So something that we notice is that a lot of engineers, although they have sort of a basic understanding of finite element analysis, they're not really acquainted with how it works or where it came from. Typically, there aren't very many sort of formal education opportunities to learn about finite element analysis, even though it's more widely used. So that's really a great benefit of attending this course, is that you'll be able to receive sort of formal lectures on what finite element analysis is and how it can be used. It's something that it's a skill that's very important, but once again, as far as any sort of universities that offer it, they're very limited. So that's something very unique you'll be getting out of these courses, is you'll be able to learn the basics of finite element analysis and numerical modeling, and how you can, sort of use it. Naturally, we'll compare it to conventional methods. So although finite element analysis is being more and more widely used today, it's still being used hand in hand, or it's being used as sort of a hybrid with conventional methods. That's really the most effective way to go about using finite element analysis, because although it's very powerful, there's still some things that you'd want to check with conventional methods, and there's still some steps that you can do with conventional methods that would make a more sort of seamless transition. So with finite element analysis, it's not really replacing what engineers do, it's really sort of supplementing it. So just think of it that way. Just by attending these courses, you're not really learning something that's going to replace what you're working with, but something that's going to enhance what you already have. So that's what we hope, that with finite element analysis, you'll be able to build upon what you already have to work more effectively and more efficiently. So then, after we compare to conventional methods, we'll have a third quiz. And then finally, we'll go over certain case studies. So here we'll talk about high-end and conventional project applications of finite element analysis. In other words, actual projects that were completed through the aid of finite element analysis, how it was used, why it was used, and what sort of advantages and obstacles, how certain obstacles were overcome through the advantages of finite element analysis. So that's a very important section that can really sort of help you bridge the gap. Like, okay, and in these first three sessions, or in this third section, you gain an understanding of finite element analysis, how it's used. But in the fourth chapter here, the fourth section, you can sort of bridge the gap to why it was used and how possibly it could be used for projects that you're working on right now or would be working on in the future. Okay, so here is just sort of an overview of next week's session, session 1, and here we'll be going over an introduction of numerical modeling for geotechnical applications. So this is the very first course or first lecture. So the main purpose of this course is to provide a general review of conventional and finite element analysis methods. So in this course, we'll be reviewing, sort of methods that are that you're already familiar with as far as geotechnical work. We'll be discussing theoretical backgrounds, why they're used, where they're used, advantages of each one, and then also we'll be going over finite element analysis methods as well. So we'll be reviewing what you already know, but we'll also be introducing you to some newer concepts as well. And as far as contents, so first we'll go over applications of numerical analysis in the geotechnical engineering industry. So we'll go over how numerical analysis has made certain considerable changes to the industry, how you can use it in your own projects, and why specifically it's being used more and more frequently now. And then key theoretical principles of numerical modeling. So we'll introduce the first main or the main basic concepts of numerical modeling, help you sort of get a grasp of sort of the fundamentals or the foundation of the principle of numerical modeling. And the comparisons of conventional methods for geotechnical design. So this also, is very key. So we'll discuss why certain conventional methods may be better used for some projects, whereas with other projects, maybe finite element analysis can be used to supplement methods that are already being used. So we'll start off with a very broad definition of these terms, and then we'll start to get more and more specific as we introduce comparisons and then also case studies. Okay, and then here just is a preview of a couple of case studies that we'll do. So we'll go over the Pentaminium Tower in Dubai. So once again, this was used, finite element analysis was heavily used in the design of this, of the foundation. As you can see, it's a pile foundation, complete with several basement levels here. So we'll discuss how finite element analysis was able to provide engineers with a unique sort of set of tools to help them overcome certain design obstacles, and how it was used to help them to sort of optimize their design, to cut down on cost, and sort of work more efficiently. Then we'll also be talking about a bulkhead project that was done in Louisiana, very recently. So this is something that we worked on with a company down there very recently. They just started using GTS, and then during our project support, we were able to support them with this particular project. There was a series of sort of challenges that were faced, and we'll just sort of show how numerical modeling was used to address those problems as well, and we'll also talk about the sort of results that were obtained as well as the final design. And then we'll also be going over a couple of conventional sort of projects. So the projects that I showed you were sort of higher end, more complex, but I'll also show you how finite element analysis can also be used for smaller scale projects or simpler projects. So here we have a conventional seepage type project. So here we just have the sort of contour diagrams or the final analysis results of this particular project. So here the water was on this side of the dam. That's why the head changes. So red is the sort of more critical or the higher values for head. And as it goes to the right where there isn't any water, as you can see, the head sort of starts to decrease or goes to the blue. And also using finite element, you can get hydraulic gradients or flow paths. So this is something that's really special about finite element analysis, is that steps that previously took much longer to do or to calculate with spreadsheets and conventional methods can now be done very quickly and very efficiently using finite element analysis tools. So that's just one of the key things to remember about finite element analysis, is that things that took a much sort of a greater sort of investment in time and effort to do with conventional methods, finite element analysis can greatly decrease the time and effort that's required to complete those types of projects. That's something that we'll go over in greater detail. So finite element, although it's typically related to larger scale or higher end projects, just keep in mind that it's also extremely useful for conventional projects as well. Okay, and then here's just another case study that we'll go over. So here, we have the seepage combined with a slope stability project. So we'll be talking about coupled analysis later on, or analysis where sort of two analysis types are used. So with a coupled analysis, seepage is combined with slope stability just to account for the effects of rainfall. But just here, we just have the completed sort of solution set for a finite element analysis for a particular slope. So as you can see, you can get everything from the displacement, the shear stress, the strains, and the displacements both horizontally and vertically, and principal stresses just with a single analysis. So whereas conventional methods, you'd have to run a different sort of methodology for each one of these. But with finite element analysis, you can do all of these within a single file. So I'll go into more detail about that later on, during next week's session. But once again, just keep in mind that with finite element analysis, you can really consolidate or streamline your work. And we'll talk about how this can be used in a practical sense next week. Okay, so now session 2. This will take place the week after next, on the 13th. And now we'll be discussing numerical analysis for foundation design. So the purpose of this particular session is to provide a comprehensive review of practical pile foundation analysis methods. So for example, the reason that we're going over foundation design in particular is because we did sort of a survey of all the different engineers we contacted, and we found that foundation design was something that everybody, or mostly everybody, wanted to learn about. So just based on the feedback that we received, we'll be going over foundation design, because this is something that seems to be in the forefront of a lot of engineers that are working today or working now. So contents. First we'll be going over the key differences between conventional PY method and numerical analysis. So as far as, for those of you who have experience doing pile analysis, the PY method is something you should all be familiar with. So we'll be discussing how that compares to numerical analysis, more accurately or more definitively, how it's combined with numerical analysis to obtain better results. And then unique benefits of numerical analysis for foundation design. So we'll go over certain benefits that numerical analysis offers specifically for foundation design. Then Power Raft foundation design. So that's actually another reason that we're going over Power Raft foundation in particular, is because this is something that came up in a lot of sort of the surveys when we talked with you over the phone, or when we talked with engineers in the past. We asked them, what they wanted to learn more about, and they said Power Raft foundations was something in particular that they work frequently on and that they wanted to learn more about. So we'll be discussing sort of the intricacies of Power Raft foundation design. So here's just sort of a screenshot from that seminar. So as you can see, we'll be discussing not only the design of the structure, but we'll be discussing how the ground, or the type of ground material that you're working with, affects your structure and affects your design as well. Okay, and then finite element modeling. So here we have a picture or a screenshot of a finite element model for a pile. So as you can see, because it's a finite element model, there are certain steps that need to be made, and this is just sort of a progression of the steps. So we'll be talking about everything from meshing to soil structure interaction to selecting your pile type, so on and so forth. So for those of you who aren't really familiar with finite element, this is an excellent opportunity for you to just get the basics down, so that later on when you start creating your own finite element models, you have a good understanding of what everything means and how to create just the foundation or the very building blocks of your project. And then as far as case studies, we'll be going over the Abu Dhabi Tower built in the Al Reem Island. So here's just a couple of screenshots. So this was modeled with GTS, and this is just sort of the top view of the basement levels, and then also the piles in the basement itself. So we'll be discussing, how it was modeled, why GTS specifically was used, and how the engineers were able to use GTS to their advantage. And then we'll also be going over a luxury apartment complex that was built in Barbados. The reason that we chose this project was because of the sort of the unique way the piles are created. So as you can see, it was made of it was made of a series of dozens of different piles going on along the length of the foundation. So because of the way that the hotel was shaped, it required 3D analysis. So GTS ultimately was used. So we'll be discussing certain design challenges that were faced, and once again, how numerical modeling specifically was able to overcome those challenges, and how it was able to become a very sort of useful tool for engineers in this project in particular. Okay, then the following session will be on the 20th, and this will be on the application of slope stability and numerical analysis in the design process of dams. So the reason that we chose these topics for this course is because slope stability, once again, was something that many geotechnical engineers that we conversed with requested to learn more about as far as how it relates to numerical analysis. So we'll be going over that, but then we'll also be going over how it relates to the design process of dams. So for those of you who have experience working in dam and embankment projects, this will be a particularly useful session for you because it relates slope stability directly to the design process of dams, and in particular seepage analysis. Okay, so the purpose is to provide a comparison of the limit equilibrium method and the strength reduction methods of slope stability analysis. So these are the two main analysis methods that are being used. The limit equilibrium method has been used, for decades by geotechnical engineers, but now, once again, with the rise and the spreading of numerical modeling programs, the strength reduction method is becoming more and more prevalent, to the point where engineers are starting to actually sort of lean towards the strength reduction method for a lot of their projects. So we'll discuss why this is happening, why the strength reduction method is starting to be used more, and what in particular you can acquire through the strength reduction method that you can't acquire through the limit equilibrium method. And then last, we'll relate it all back to the design process of dams, or seepage analysis. So as far as the contents, first we'll be going over theoretical principles of the limit equilibrium method and the strength reduction method. So we'll just introduce the basic concepts behind them. With the limit equilibrium method, we'll discuss how it was formulated, sort of the main design principles behind it, its strengths and its shortcomings. And we'll do the same for the strength reduction method, and then also we'll compare them directly. So yes, we'll compare them directly, and we'll sort of note the key advantages of each method, and we'll also discuss the types of slope stability projects that would warrant a limit equilibrium method, and we'll also discuss the ones that would warrant the strength reduction method, or just a combination of both. And then as far as the last section, we'll discuss seepage and slope stability analysis for dam design. So I mentioned this earlier, how seepage analysis is typically used in coupled analysis with slope stability projects. So in other words, I'll go over step-by-step how you would do a seepage analysis, and then you take those results, or you take your poor water pressure loads and apply them to your slope stability analysis, and how that would affect your dam design. So here, this is just a sample screenshot of the limit equilibrium method. So we'll discuss the method of slices and how to apply the limit equilibrium method in standard numerical modeling programs. So for those of you who have SlopeW, FLAC, GeoStudio, this should all be very familiar. But for those of you who maybe would like to learn more about how you can do the limit equilibrium method with a numerical modeling program, this would be a good opportunity for you. And even for those of you who have experience using numerical modeling programs for limit equilibrium methods, this will be an opportunity for you to gain a grasp of the theoretical concepts. And then the strength reduction method. So here's just a contour diagram for a displacement. So that's one of the things that's really unique about the strength reduction method, is you can actually get, you can actually calculate much more accurately the displacement that's to be affected, or to be expected, excuse me, from your slope, as well as supports themselves. So we'll talk, once again, more about that in greater detail during the session itself. And then last, a seepage. So once again, because you have an embankment or when you have an embankment that's exposed to water, there's going to be a certain amount of seepage going through the earth dam, which could affect the stability on the other side of your embankment. So typically, once again, we'll discuss how to account for these poor water pressure loads. So as you can see, there's a certain critical area that's being affected because of seepage, and we'll discuss how to incorporate poor water pressure loads into your slope stability analysis through using numerical modeling. And as far as a case study, this is just an example of the Carsington Dam in England, which was actually a big breakthrough project for slope stability and strength reduction methods being used more commonly. So we'll discuss how this project in particular really sort of made some significant changes in the engineering world that really brought more attention to finite element analysis. So we'll be discussing this actually during the first session, or next week's session, but then we'll review once more for this final session just to really review how finite element analysis can handle certain design considerations or design challenges that conventional methods aren't capable of taking on. So just to sort of give a preview of what to expect, as far as with this dam, the reason that finite element analysis was used more, was brought to attention for this project was because of certain seepage parameters that couldn't be taken into account with conventional methods. So once again, we'll discuss that in further detail during next week's session. Okay, and then for our fourth and final session, we'll go over, and also keep in mind, for those of you who are marking your calendars, this will be 2 weeks after the third session. So for Thanksgiving week, we'll actually have an off week because, mostly everyone will be on vacation then. But, the week after Thanksgiving, on the 4th, will be our concluding session. So we'll be going over numerical modeling demonstrations of fundamental finite element analysis concepts. So our purpose is to provide an introduction to the principles of finite element modeling. Okay, so at this point, we're just sort of building upon what we've taught you in the previous courses. So in the previous sessions, we introduced finite element analysis, its theoretical concepts, why it's used, its advantages. Now the goal of this particular session is to provide you with the knowledge of how to use finite element modeling for your own projects. So in other words, we'll be going over how you can just start building your own finite element model. Because with finite element, it follows a very sort of rigid process. And here we'll be sort of familiarizing you with that process so that, after this course, you could confidently, start building your own finite element model. Okay, so as far as the content, we'll be discussing important numerical modeling concepts. So how to determine the size and types of elements, boundary, loading conditions. So for those of you who are familiar with numerical modeling programs, some of these will be, familiar to you. But for those of you who are still new to finite element or numerical modeling in general, as far as how to, create certain conditions or boundaries, there's a certain way that you have to do with finite element. And we'll discuss that in detail so that, once again, you can feel confident about attempting your own numerical analysis in the future. Okay, and then analysis methods, how to determine the various analysis types based on project needs. So we'll go over the different analysis types that are available to you and sort of how to select which one works best for your project. And then the interpretation of results, so determining deformations, the stress of ground, stresses, structural elements. So once you've run your numerical analysis, you'll have this great sort of list or sort of all these options of different results that you can sort of sift through. So one of the great things about finite element analysis is that it gives you a great sort of wealth of results to look through. However, it can be sort of difficult to find the ones that are of interest to you because there's just so many. So, the reason that we have this particular section set up is so that you can understand how to sort of extract the results that are important to you. And we'll, once again, we'll actually be giving a live demonstration just from the very beginning, just setting up your model, running the analysis, and then going over, finding the results that are of interest to you so that you'll know how it works from the beginning to the end. Okay, so for example, we'll have a sample project site, something that you plan to build or is already built. And then we'll create the geometry. So the basic geometry, the elements, the boundaries, loading condition, everything that's needed to sort of simulate that project site in the program. We'll create it. And then we'll create the finite elements. We'll create the meshing. Once again, this will just be a step-by-step demonstration of how to create your own numerical model. So we'll start from the very beginning, and we'll make sure to go over each step so that when the time comes, you'll have a basic understanding of the procedure for modeling a finite element type of model. Okay, and then we'll also go over construction stage analysis. So here, we'll start off with initial conditions, excavations, the pile installation, constructing the retaining wall, filling it, creating the embankment, so on and so forth. So we'll go over a detailed sort of instruction or demonstration of how a construction stage analysis is created. And then last, we'll go over a case study. So we'll demonstrate how to model a bridge foundation with finite elements. We'll take a very basic, very simple project, and I'll just go over the basics of, setting it up, creating the model, and running the analysis. And it will be this type of project here. So for those of you who, worked with foundation or embankment type projects, this should be something you're very familiar with. So the main thing that we're doing is we're taking something that you're familiar with, and we're showing you how it can be applied to something new, or how it can be applied to a new method. Okay, so that's it for the course summary. So now what we want to do before I let you all go is I want to discuss a really special opportunity that's available to all of you. So what we'd like to do is we'd like to enhance your design experience. That's something that I stressed at the beginning, is that our main focus here at Midas is helping you to grow and develop as professionals and to provide you with tools that'll help you, work more efficiently, that'll help you to really reach your potential. So what we want is to optimize your project results with full technical support. So how we can help you. First and foremost, when you need finite element modeling analysis for your design, we'll provide affordable FEM geotechnical software. So that's actually another reason we're having sort of a series of courses that go over more detailed the basics of finite element modeling. We find that a lot of engineers, after attending our courses, they really want to use finite element software, but they have maybe issues with budgeting for their company, maybe time, so on and so forth. So what we really do is we make sure that our software is affordable, and it's something that you can realistically start using as soon as you wrap up with the courses. So just keep that in mind, that the software is available for you, SolidWorks and GTS, and we'll discuss more of how you can incorporate it into your work process later on. And then reliable technical and project support with customized training. So that's something that's very important to us as well. We want to make sure that once you start using the program or start using the software, you'll be able to rely on us to provide really reliable support and training. So we'll be with you every step of the way as you start using the program and as you start using it for your projects. Either myself or one of my colleagues typically will be assigned to personally assist you with whatever you're working on, so that you can take full advantage of the program, so that you can remain productive. So as you're learning, you're also completing your project. And then continuing education program. So naturally, this is what you're all enrolled in. As far as our continuing education programs, as I said in the beginning, we make sure to choose topics that are very relevant in today's industry, that are interesting, and that are things that you can apply directly into your own projects, into your own workload. And then also, because we're AIA approved, you'll receive professional development hours for all of your attendance. Okay, so common concerns. So typically, so one common concern that comes up is that, maybe you have a project to utilize advanced analysis, but no trained engineers. In other words, you have a project that, could, where finite element analysis can be applied, but no one feels qualified to really start using it. So as far as an answer to that, we have a full staff of finite element engineers to support you. So once again, I myself am an engineer. I have a good amount of experience with finite element analysis, and typically what I do when I'm not teaching courses is I provide technical support to engineers from various regions of the country as far as how they're using the program, and I make sure that they not only have their projects done in time, but I make sure that they understand what they need to do in order to take full advantage of the programs. Just keep in mind that if you're hesitant to start using finite element analysis because no one's really there to teach you, you can really just rely on us. We can be here to teach you, to support you fully as you start using the program for your own projects. So another issue that comes up is, engineers don't know how to implement finite element into their current projects. So as far as that, we will provide you with instructions throughout this course. So for example, I understand that most of you are enrolled in these courses because you work in pile foundation type projects, as well as stability projects. So, we'll provide you with instructions throughout this course in particular. So this really is the beginning of starting, or excuse me, would be how you would develop a foundation in finite element analysis as far as it relates to this project. So after this course, we'll be going over a lot of material, but you should feel confident to start using finite element analysis at the end of it. If not, you can come to us directly and we can sort of fill you in the spots that you missed or parts that you're not confident about. So just keep in mind that we're here to support you as you begin sort of incorporating new design methods into your work method. And then this is another common concern, is that engineers feel that they don't have the budget to purchase software. So one key thing to remember about our company is that money really isn't the most important factors for us. Really, the most important factor for us is that you're able to use the software, that you're able to benefit from it. As far as the cost, we're flexible. If this currently is an issue for you, say for example you attend the courses, you look into the software, you find that it would be a great fit. But as far as budgeting, that could be a limitation for you. Just talk with one of our sales associates and they can help you work out something that works best for you. Once again, just keep in mind that our main focus is to enable you to use the program. So oftentimes we have companies that will maybe go on over an installment sort of type payment where they can start using the software right away, but they don't have to pay at the moment. Those are all options that are available to you. It's just a matter of going over your situation, and then we can talk about how best to sort of suit your needs so that you can start using the software right away. Okay, so this concludes the course introduction. Thank you all for attending. Next week's session will be next week, November 6th at 3 p.m. Eastern Standard Time, and we'll be going over the introduction of numerical analysis for geotechnical applications. So for those of you who have any questions after the course or after we wrap up, feel free to send me an email or to send me an email through the company address, MIDASoft@MIDASuser.com. You can also feel free to call me directly. This is my direct line to my office phone. So once again, thank you all for attending. If anybody has any questions, now is the time to ask. Once again, just type into the chat box, and I'll be checking it now. Okay, so another question, is there a cost for registering after the deadline? Okay, so yeah, if you have a colleague that's interested in registering, just make sure that they register by the end of this month, otherwise there's going to be a registration fee. So we only have just a couple of seats left, so make sure that they register today if they're sure they want to attend. That way they can attend, or excuse me, they can have the registration fee waived and their seat will be reserved. And then later on, if you can't make it, just send me an email and I'll free your seat up for the next person that wants to attend. Oh, okay, so to learn more about the software, just go to MIDASuser.com and just click on the Geotechnical section, or the Geotechnical tab. And what you can do is you can go through SoilWorks and GTS. It goes into much further detail about what each program has. So yeah, that's MIDASuser.com. And yeah, we can talk later about that issue. That's a little specific. Yeah, you can just you can just give me a call later on today, and we can go over that particular project. No problem. Okay, so yeah, okay, no problem. Let me sort of go back here. So the question was, they just wanted to. This gentleman just wants to go over the software again. So I'll back up here. Okay, that'll be faster. So yeah, the main difference between GTS and SoilWorks is that SoilWorks is typically used for conventional type projects or 2D analysis, and GTS is used for 3D analysis. So yeah, just go to MIDASuser.com, and then you can go into you can learn more about each program there. Yep. Okay, so this question is, if I can't attend during the live session, how can I watch it later? So what you can do actually is just what we'll be doing is we'll be posting all of the sessions online, just on YouTube. So if you can't make it to the session, just what you can do is you can just wait till we release the links to the videos online. And then what you can do is you can just request a copy of the quiz. I'll send it to you. Just submit it to me by a certain deadline. Usually it's a week after the live session. Just submit it to me by then and you'll be fine. Yeah, so for those of you who can't attend the live sessions, just keep that in mind, that we record all of our sessions for future reference. So make sure just to give us a heads up. We'll send you a copy of the quiz. Just submit it to us by usually within a week's time, and you can still be eligible for the credits. So that's one of the key, that's something actually I forgot to mention, is that one of the key advantages of these courses is that they're very flexible. So even if you can't make it to the live session, there's still a time that you can watch it later. Okay, so this question is, when can I receive the PDH certificate? We'll send the PDH certificates out at the end of the course. So after the December session, usually a week after that, what we'll do is we'll have the certificates ready for you, and we'll send you an email. And all you have to do when you're is print out the certificate, and then later on when you're renewing your license to the licensing board, just include a copy of the certificate, and that'll vouch for you that you earned the professional development hours. Okay, so I think that's all the questions we have for now. Once again, yeah, thank you for bringing those to my attention, bringing those concerns to my attention. And once again, if you have any questions afterwards, feel free to send me an email or to give me a call. I'll leave my number over here. Once again, my name is Daryl, and I'm with Midas. So thank you again for your attendance. We look forward to having another course, or having these sessions with you. And until next week, take care.